Question number 6, the final question on the emailed copy that I sent you. They start out by giving you two rates. Rates E of t, which is the rates of the rate of the bees entering the hive, and L of t is the rate of bees, the rate at which bees are leaving the hive. Question A is asking about from 0 to 2, how many bees are leaving. So to go from a rate to a quantity, you do the antiderivative. So we're going to go from 0 to 2 of negative 2t plus 5. So the antiderivative is negative t squared, and then plus 15t, we're going from 0 to 2. So this would be 2 squared is 4, so we've got negative 4 plus 30, which would be 26. So that, in terms of units, remember these are talking about hundreds of bees. So it's 2,600 bees. Leave the hive. All right, now on to part B. Part B says write an expression. So the expression is going to consist of 0 to 4 of E of t dt minus, no, it wouldn't be dt, minus L of t dt. And that would equal to bees entering, bees leaving at 4 and then you have your bees at 0, and the bees at 0 would be 3,500. So now pull that to the other side, so we get 35 plus, all right, now this is the integral from 0 to 4 of E of t minus L of t. Now I'm just going to write it out. If this was a calculator problem, I wouldn't bother writing this problem step out because it would be left in the equation. But E of t is going to be 16 minus 3t squared, and then you have minus 2t plus 15. So 16t minus negative 2t would be 18t. And then the terms that you haven't combined, you've still got your negative 3t squared from up top. And then you have your 15. So that's going to be minus 15 here because it's subtracted. And that's going to equal to the bees at time 4. So 35 plus, all right, this becomes 18t squared over 2, which would be 9t squared. Negative 3t cubed over 3, which would be negative t cubed. And then minus 15t. And we're going from 0 to 4. So, again, plugging in 0 here, that goes away, but you got 9 times 4 squared 16, so that's 144. Minus 64, and then minus 60. All right, so that's 124. 144 minus 124 is going to be 20, so it's 35 plus 20, which would be 5,500 bees. Okay, and now on to part C here. As you can see, I did not erase the problem from earlier today. So let me take that one off. All right. So the next thing says find the minimum number of bees in the time. All right, so we want the critical number. So we want where the rate is equal to 0. Remember, these are both derivatives. So all we're going to do is take this equation of E of t minus L of t, and set that equal to 0. So from here we get negative 3t squared plus 18t minus 15. And we can factor out a negative 3. And this becomes negative 3 times t minus 5 and t minus 1. So t equals 5 and t equals 1. Now we can rule t equals 5 out because it does not fit the window frame from 0 to 4 that we're looking for. So here we are. We start off with t of 1. So there are 3 times that we're interested in. Remember, absolute extrema can exist at endpoints, which would be 0 and 4. So we want to know how many b's there are at 0, how many b's there are at 4. But we also want to know how many b's there are at 1. Well, earlier we solved the number of b's at 4. The number of b's at 4 is 5,500. And we already know the b's at 0. The b's at 0 was the original number they gave us. And that was 3,500. So now we need to figure out how many b's are in the hive at 1. So it's going to be 0 to 1 of we start off with 35, so it's 35 plus that. So 35 plus, all right, we've already done this antiderivative once. It's 9t squared minus t cubed minus 15t. And we're going from 0 to 1. Okay, so this becomes 35 plus 9 minus 1 minus 15. So that's negative, or that's 8. 8 minus 15 is negative 7. So 35 minus 7, which would be 28. So 2,800 bees is the minimum number of bees that are in there at a time. So, and that happened at 1. So that happened at the critical number. Now, what they do want you to do is they do want you to do one of 2 things. You can either test the endpoints and test the only critical number in there. Or another thing you could have done is if you could have said, okay, I know a critical number exists at 0, and then proven that the derivative is negative on the interval from 0 to 1, and then proven that the derivative was positive from the interval from 1 to 4, then you could have said, well, it's got to be a minimum at that point. This is easier to do because this, you've already gotten that number and you've already gotten that number, so if you get this concrete number, then you're done with it. All right, so that's it for the emailed packet. I hope that you've done well. You can kind of calculate through to see how you felt like you did on it. If you have any questions about how much something would have counted off, don't hesitate to shoot me an email and we'll get through that and I'll answer those questions and then be looking for another problem of the day. Again, if you have any specific problems that you would like to see worked, please do send that because I will be more than happy to do those.